Hello and welcome once again to Global.Science, our podcast on science, education, and communication. So, Fabia, have you read anything interesting in the news? I should introduce myself first. I'm Lev Hordisky. I am co-host of this podcast, and Fabia is
Fabio Battistuzzi, another co-host of the podcast. Well,
so
we are the
news.
only two, so.
Yes, unless we have an imaginary one. We don't have an imaginary one yet, do we?
Well, I don't know about that. Maybe I'll tell you next time.
That is troubling. So news, science, good, bad. Have you read anything interesting in the news? You sent me an article today about some flying beetle that use like feathers to fly, and it was pretty cool. But was it directly from the Nature site, nature.com?
Yeah, it was directly from nature.com, which is where I get a lot of my, kind of science news without actually reading the scientific articles, because I don't have the time and I wouldn't understand probably 90% of them anyway. It's, I use Nature, I use Science, the journal Science. I use sometimes other sources of scientific information, but a lot of the science news that we read is not necessarily particularly good for a variety of reasons.
Yeah, and so the website that I typically use for science news is Ars Technica, because I also don't have time or patience to read a whole lot of scientific papers. I know some of my friends read them for fun. I'm not sure what's wrong with them, but at least for me, I like the summary, but I have taken issues with sometimes the coverage. I remember writing to the editor once because they would use a generic term like, oh, scientists discovered. And I was like, I knew the scientist, and it was someone I worked with. So I inquired why there was no name there. Why didn't you say which scientist had written it? And I got a response back that said, oh, we don't have time to do personal profiles of everyone. And I replied, it's not a matter of doing personal profiles, just name the people who do the work. It's like reporting on a soccer match and saying, today, a player scored a goal in this game. And like, no one would take that kind of sports coverage seriously if you said a sportsman scored a goal. I mean, is that how they report on soccer in Italy?
Oh, no, you have to tell the name, because you have to be able to say that so-and-so was excellent or so-and-so was an idiot because he missed the goal. So it's very important to have names.
And we kind of need to do the same thing in science. So, but it was interesting after I sent that note to the editor, I noticed that they started naming the scientists more often than not. And now when I read articles there, they'll name check the people who actually did the work.
Nice.
So that's been an improvement. But aside from there, when I look at science articles elsewhere, I just find them very, very lacking. I know that there's an article out there called This is a Scientific Article, and it was written exactly like a scientific article. It said, the title was, This is a Scientific Article. This is the introductory paragraph. This is a summary of what I remember from middle school science about the topic. This is what the study said. This is what an opposing scientist said. And who knows, more research is necessary, end of article. And I find that a lot of science news articles kind of follow that pattern.
Yes, and to be perfectly honest, if you find a science news that follows that pattern, you are almost lucky, because the ones that don't follow that pattern actually end up saying things that are plain wrong. I mean, I have read scientific news and then read the actual article, and whatever the scientific news said was not what the article was saying. Either it was incorrect or it was just not the major point. And so it's there are many levels of complications when we read the science in the news.
And I think that's what makes science news coverage difficult. And this is definitely a topic I teach in my class, where I actually give students I flash a slide up for my students that says, hey, we're going to talk about brains. And I have 3 pictures there. One is of a diagram of a brain with different parts colored. One is a brain with like 2 eyes, like an alien flying brain. And then another one is a brain with like 4 segments, got like chess pieces and playing cards and explosions and all sorts of stuff flying out of there. And it just looks like background imagery. And I don't mention it aside from saying, hey, before we talk about science, let's talk about how brains work. And then I get into all the brain biases that we have, like inattentional bias, confirmation bias, and things like that, to help students understand why science is structured the way it does. And what I do at the end, like about half an hour in, I ask them to recall details of the picture that I had flashed there. And inevitably, the brain that has the highest recall rate, most correct description, is the one with two eyes. It's not the one that's overwhelming with information. It's not the one that's just a boring diagram. It's the one that is a flying alien brain. And I use that to teach students that sensational information is what our brains retain really well, and correct information or bland information or overwhelming information are ones that our brains do not transmit very well from brain to brain or just recall over time. And I got that out of a psychological study that I was reading. And the point I make is that where you got the flying brain, that's basically gossip, and it moves around really fast. The diagram and the overwhelming information, that's basically science. And so that's the problem we run into when teaching or communicating science, is we need to transmit information that our brains are just not very well equipped to relay faithfully, because it's not gossip. So
right. And so, like everybody says, the burden is on the scientists to basically learn how to communicate their knowledge or whatever they discovered in a way that the public will be, in a sense, happy to consume and happy to read. Obviously, there is a language barrier, a style barrier in the way we communicate, and honestly, in part, is also sort of a training barrier, because scientists often are not trained to communicate with the public, and so it's something that we have to learn, right?
exactly. And I think this would be a good time to introduce our guest today, Dr. Steve Desch, who is, I like to refer to him as my totally real professor friend, because you didn't believe that he was real and that I was talking to him during the pandemic when I was alone in your house for like 3 months.
No, but to be perfectly honest, it's because you were also talking to my squirrels for 3 months. And so I had a reasonable doubt.
So Steve, welcome to the show. As you can see, it's it's a bit insane.
Thank you. Yeah, that's okay. I was just storing away my nuts.
Oh. All right. So we're interested in talking to you because you actually work on communication and science for fun. And right before we started recording, you said that you do it poorly.
Right, I do. I wasn't trained at all to communicate to the public, and I think that most scientists aren't. And I didn't really appreciate how much of an obstacle this is. I understood that there's a barrier, but I never appreciated until recently just how much is incumbent upon the scientists themselves to figure out how to communicate to the public. And maybe I'm an idiot for not realizing that sooner, but the movie Don't Look Up prompted this thinking in me, and it made me realize we need to understand how the majority of people understand information, kind of like the psychology that you were alluding to.
Yeah, and you wrote an article about this for Slate, slate.com, about this problem that scientists, that the movie did a good job of skewering the political and media environment in which the asteroid conversation was taking place, but also did a pretty good job of skewering the scientists and the academic establishment for being unable to communicate the urgency of the threat very effectively.
Yeah, that's right. It did. And that's what I said in the article for Slate. And I don't know if that was the intent of the filmmakers. Even reading the production notes, I understood this is clearly about climate change. It's about the inability, for the communication to happen between the scientists and the public about how severe the threat is. But it's a little bit not explicit that the scientists share some of the blame. And it occurred to me throughout the movie that they were always admonished to get media training and figure out how to get their message out. And They did evolve a little bit. They tried, they learned, but they never really understood that this was something that they had to devote themselves to do to change their own behaviors.
So what prompted you to actually write that article and start engaging in this public communication?
Yeah, that's a very interesting thing, that Slate has this relationship with a few places, including ASU, the Future Tense initiative, and they were looking for scientists to write articles like this. And so every once in a while, I will get asked to write an article. Usually it's about aliens or movies about aliens, movies about space. So I wrote one on Mars attacks. I wrote one on Arrival. That was the first article I wrote that got me into
Nice. I like that movie.
It's a great movie. It's a real head scratcher. And that movie and a few others made me think hard about how the information, in that case, it was the information that we're not alone, that aliens exist. Mars attacks, that the aliens are kind of jerks. And other movies that make you think, how is information digested by the public? And another article I wrote for Slate was about Oumuamua, this interstellar, let's call it a comet because it is not a spaceship, but that's another instance where a scientific fact has to be communicated with all its nuance to the public, and it's done pretty badly.
What's the nuance that's typically lost when we transition from talking amongst each other to talking to people who are not scientists?
Right. I think some of the basic tenets of science are missed. So as scientists, we're trained to understand that you have hypotheses and you can disprove hypotheses and you can never prove anything. And we're used to that. That's the way science works. It's the crucible. You burn away everything that just is obviously not true. And what you're left with is maybe true and maybe not. And that's just how we deal with it. But that's not how the public thinks about things. And another aspect is just the numeracy. So in that movie, Don't Look Up, Leonardo DiCaprio expresses the fact that there's a 99.92% probability that this asteroid will collide. And the reaction is, oh, so you're saying there's a chance that it won't. And so it leaves room for wishful thinking. Most people just don't intuit numbers in the same way or understand risks and probabilities in that same way. So these are some barriers to communication.
And I think we see this also when we teach our students. So I know that one of the things that I see a lot, my students, they usually do a final project and they have to write their paper on whatever data analysis they did. And so often they tell me that analysis X proved that, and the word proved is the one that I always cross off. It's like, no, you didn't prove anything.
Right, that's the scientific method, and we've learned not to do that, and we're always struggling to get a better approximation of the truth. But people want to know whether it's safe to eat eggs or whether it'll give you high cholesterol. They don't want nuance. They want to know how to incorporate that information into their everyday lives, and they don't have time to think too hard about it, and that's understandable.
I think that's been especially problematic with the COVID pandemic, because all these nuances end up getting lost when you're trying to make very rapid decisions, because a lot of, like you mentioned, science is a crucible. It burns away the things that are definitely untrue and leaves something that's probably true, but it may not be the whole truth. You may need to burn away more of it before you get at that one grain of truth. And usually we have the luxury of time to run through those experiments and burn down to that kernel of truth. But with the pandemic, we weren't able to do that. We had to make decisions in an information sparse environment. That's actually something I'm working on in the Greenworks project for Science Voices, getting students to become familiar with making decisions in uncertain environments, slowly going from the most certain scenario to the most uncertain scenario that requires the most drastic action the quickest. And the students have difficulty coping with the fact that you may need to make a decision, even if you don't have all the information. And that means you're going to make mistakes.
Yeah. I mean, the pandemic is a perfect example, obviously. And, the issue of masks, do they work? Do they not work? And that's not a binary answer. They have an effect. You can quantify it with some uncertainty, and all that has to be communicated. They do reduce the transmission. It's not enough to guarantee you would be safe, but it's definitely enough to prevent the virus from running away. It reduces the R value, if you will. So depending on the question asked, it could mean one thing, it could mean another thing. There are answers, but the media is not very good at conveying what question is being asked and the answer to what question. And it's always a binary: good, bad, works, doesn't work. So.
And I think you bring up a good point that one of the issues is not just in the way we communicate, but in the way the questions are framed. And I think, again, with the pandemic, but also with other recent issues that have put scientists and the public at odds, like climate change or even evolution, which is my field. A lot of it is these kind of issues expose the frustrations that both sides feel. The public that wants answers and feels like the scientists cannot give answers, and the scientists that are trying really hard to give answers, but we are constrained by what we can do with our tools and the uncertainty that is around the knowledge. And so framing questions in a way that would help sort of bridge this gap of frustration might actually be a good idea. The problem is that it's very difficult to do, I think.
Yeah, and I share the frustrations you have about the way articles are written. And the first thing I, as a scientist, want to know when I read an article is who did this study, and do I know them? Am I familiar with their work? Yeah, and I feel like, well, maybe that's just me wanting to know the score, if you will. But then I thought about it. It's like, no, it's just basic journalism, right? The who, what, when, where, what. How can you write an article with the who? But I think another aspect is the why. Like, why was this research done, and what was the question that motivated it? Because unless that is conveyed, you don't have context to understand how significant the study is, or does it negate something else? Well, no, that was a different question they were asking. That would help a lot.
I like that you mentioned the context, because that's not a way I had previously thought about scientific or news coverage of science. And I think it's critically important. And what can we do to better instill that context?
As scientists or as people writing about science?
I'm wondering both, because and I remember having a conversation with a journalist and expressing frustration that science coverage was so bad, and saying like it's the journalist's fault. And I remember sitting in on a talk somewhere. It was a conversation between journalists and scientists, and the journalist said, you have to do more, you have to do more, you need to convey more information. And I wanted to ask the question, I may have asked the question, like, how much more do you want us to do? Do you want us to do 50% of the work, 60, 70, 80, 90% of the work? If we're doing 90% of the work to communicating our information to the public, what exactly are you doing? And when I was talking with this, she was a former journalist, and what she had mentioned was, she told me, think about the journalism profession, that it is a business, and most of it's a business that requires clicks and attention to get money. And what are the things that will get clicks and attention? It's typically going to be business, and it's going to be politics. Those will get the most attention, the most money. So as over the decades, as the coverage has shifted in that direction, it's moved away from basically any other field. And so you end up with journalists that are on the science beat, but there's no money there because all the money is in politics and business coverage. And so can you really blame them for not doing a good job if those departments are underfunded?
Yeah, that's an excellent point. And I don't think I can solve the business model for the dying field of journalism. It's pervasive. Even the politics beat is underfunded. All I can do is say what I think would make a better article. And I know when I have to write my own scientific articles to my peers, and when I write proposals to try to get money, or when I tell a student how to write a paper for their class, the thing that is usually lacking is better context, better background, and better framing of why am I doing this? And you have to start with that. Why am I doing all this math? And it's just too easy to get caught up in the details of the math, of the model, of the experiment, of the observation, or whatever is the hard work that the scientist is doing. And it's easy to lose sight of the context. Why did we go to the telescope to look for this thing? Why did we put this acid in this beaker? And what were we hoping to answer? What question were we hoping to answer? There's always a question, and a paper, a proposal, or an article about a paper, or an article about an experiment is always better when that question is posed and asked. And maybe it isn't fully answered or something. A lot of science is incremental, but that's fine. At least you know which direction we're heading and you have that context. So I think that because science has a lot of hard parts in it, I just think a lot of people give up, and they're like, oh, I could never program a computer like this. I couldn't work in a lab like this. And I just think the whole thing is hard, but it isn't. It's always at its heart a question that anybody can understand. It's and at some level, anybody can understand almost any of these questions, but they have to be posed like that, and somebody has to communicate that. And that should be what most of the articles about. And who did it?
I completely agree. And I think that is the way, that is the connection point between a scientist and somebody who's not a scientist. At the end of the day, we all have questions. And that is what we can use to connect with each other.
Right. Yeah. And I think it would remove some of this stigma. Science is often portrayed as received wisdom coming down from the hill. The guardians of knowledge or something have bequeathed this to the public. Eat it up, people. And it isn't. We have questions. We have more refined questions as scientists. We have more focused questions that can be answered with experiments. But they're, like you say, just questions. We all have questions.
Yep. It's the eternal children that scientists are. Just keep asking why?
Why is that?
Why do you think that is? Wait, no, is this becoming a therapy session now?
Oh, you don't want to go there.
How do you feel about your mother? So I'm wondering if there is a different approach we could take. If journalism funding is kind of slashed to the bone, there's not much money for science coverage. And I do like the coverage that Ars Technica does, because what they do very well, I think, in their science coverage is they do talk about the framing question and why was this study done and what are the implications. But I know also we've started developing some channels that are outside the normal media. And what comes to my mind is what happened with the arsenic life story that came out like 10 years ago, that a lot of that discussion happened on blogs of people rerunning these things in real time in blogs and posting it and talking about it there, because the media just kind of jumped on the hype wagon of what arsenic life meant and wasn't able to look at some fundamental flaws in that study.
Well, yeah, I mean, rumor travels around the world before the truth can get its boots on. And there's definitely economic pressure to have sensational news. And it's arsenic in life, it was like 2008, but since then there's been phosphine on Venus and
Yeah,
it never ends. I don't know. These pressures are always going to be there. All I can say is people who are serious about the craft and are serious about communicating and teaching the public need to provide the context.
So what do you think would be a good way for somebody who's interested in science communication to start getting their feet wet, to just get an idea of, how would it, what does it look like to write an article either for Slate or some other source? What does it look like to write a blog? We read them, but reading and writing are two very different things.
Mm-hmm. I don't have all the answers, but I do think that I've seen a difference in the articles that I've read, that I know they talked to the scientists and when they just haven't. And I've written material and it's been talked about in the press. And sometimes the person has contacted me and they ask good questions, and I'm usually happy to take the time to explain it and answer even their follow-up questions. And it's very annoying when somebody writes about our work and hasn't even written me or asked about it. So that's the first thing. Scientists just love to talk. So
hence the podcast.
Yes, hence. So that's a really good starting point. And I think that I don't know, I can speak for all scientists, but I've spent sometimes a long time providing a lot of context about why I was doing this work and how this other result fits in, and so avail yourself of those resources of people who are willing to talk, and there's always somebody willing to educate you on the nuances of that particular science topic. But I do think that there's a role for just journalistic skills, and I think a lot of scientists lack this, just the ability to frame the story and answer those who, what, where, when, why sort of questions, and make it into a story. Sometimes scientists aren't as good at that as they should be. So
yep.
So I think I have one final question for you. Were you upset when the journalists of The Onion didn't contact you about your study? You're, I think, my only friend who made The Onion, and I think is that a higher honor than a Nobel Prize?
Yeah, I'm gonna take it. Yeah, we wrote an article, and this came out in 2016. I was alarmed about climate change, and I thought that there should be some sort of research into ways to prevent ice from melting in the Arctic. And just as a thought experiment, we talked about it in this article, put some numbers to it, like how you could pump water and keep it from and help it freeze over the winter so it doesn't thaw as much in the summer. And it did provoke a lot of discussion, and it had the effect I wanted. I talked with a lot of climate scientists who realized that, yeah, we can't just have a taboo about talking about these things because the climate's changing too fast for us to just pretend CO2 levels will go down, So it was provocative, it was good. But yes, The Onion wrote about it, and it was the Voices of America responding to the question. I wasn't named, but it was clearly us because it was about scientists at Arizona State. And they said, oh, pouring water over everything is such an Arizona solution.
I think that made me laugh.
It was a great honor. You know what, though? I'm going to say this. And the other one was like, this is what happens when you cut science funding and so on. The points raised by those three Voices of America were exactly poignant. They actually hit the nail on the head. Like, what are some of the big issues? Why this looks like ridiculous science? And it was some of the smartest responses I've seen anywhere. So yeah, it takes a lot of intelligence to make good humor, and The Onion is really good humor. Yeah. So I didn't mind being lambasted in the Onion.
Yeah, and those are usually the ones I read because it's basically 3 sentences that cut right to the meat, right to the heart of the argument. With like, it takes skill to do that for some of these topics.
Yeah, and it really does. And I think this makes the point that we've been making. There is a way to effectively communicate with the public. You don't have to get into all the jargon. You don't have to make the issue confusing. You can communicate it very simply. And, just anybody can do this. Any science question can be posed as something very non-scientific sounding.
Well, excellent. Thank you for your time. And if I recall correctly, that study was about refreezing the Arctic using giant fans. So I'm assuming that you were some kind of secret supervillain, and you just need to protect your layer.
Yeah. I took over the Fortress of Solitude, and now I need to prevent access to it. We've evolved a little bit. It's you just have to pump the water. So windmills could do it, that would work. But I think actually there's better ways to pump water. But that's another study someday I hope to do.
All right, excellent. Well, thank you so much for your time.
Thanks, guys.
Steve.
Talking with you.
So, Fabia, do you think you'll ever make The Onion for any of your research?
I don't know about that. I don't think I have anything as fun and intriguing as what Steve has proposed. But I do agree that sometimes to just make fun of an idea, catch the attention of the public, and then from the initial making fun of, it becomes an actual conversation. And so that's a fun way of doing science, I think.
Yeah. And for our audience that's not familiar with what The Onion is, it's a fake newspaper. It was like the original fake news, and everyone knew that it was fake news. It was just done to make fun of real news. But they write satirical articles that kind of have good points and elucidate things that aren't typically said in polite conversation because, oh, you're not supposed to talk about these topics, or you're supposed to give both sides of every argument, even if there's like 5 sides, or even if there's one side, or even if one of the sides is outrageous.
It's an interesting way of discussing topics without getting caught up with a serious conversation.
Yeah, although it could lead to serious conversations. Have you ever had to deal with the media or the news for your research or research or things related to your field of study?
Yeah, so a long time ago, I was still a student, a graduate student, and one of our papers got picked up by the media. But because I was a graduate student, it was primarily my PI who did the media conversation, which I was very grateful for because I did not want to deal with the media. I could barely, have a semi-intelligent conversation with my classmates. I don't think I would have been able to handle the media at the time. But I know that it's something that we're looking into at my institution. For example, we are starting a series of media workshops to try to help faculty basically learn what does it mean to talk to the media, how do you do it, but in a lot of cases it's just really getting somebody comfortable enough that they feel like they can write an article or they can write, a Twitter post, whatever it may be, big or small, it doesn't matter. It's all a way of interacting. And so, yeah, I think it's something that a lot of institutions are looking at more and more.
Do you think institutions could do a better job with their press releases? Because I know oftentimes the media gets alerted to scientific discoveries through university press releases. And I know sometimes the origin of the misconceptions sometimes start in those press releases.
Oh, yeah. I think part of the blame starts within institutions, and it's not really a question of, blame. It's just a question of that the miscommunication starts very, very early on in the chain. But I think that's, in part, what you are trying to do with Science Voices is sort of, tangentially addressing this issue, because if you get to connect the scientists straight with the public at a very early level with the students, then a lot of this miscommunication doesn't even happen, because the students grow up basically in an environment where they are constantly exposed to scientific terminology, and so they're used to thinking that way, and the scientists are used to talking to the students all the time. And so I think some of the activities that you are doing will help mitigate in the long run the issue. The problem is, what do we do now?
Yes, thank you for boosting my collapsing self-esteem.
We all need a boost once in a while.
Yeah, I think I'll note that if I recall correctly, when I was at Arizona State University, on the list of emergencies on the wall they had, there was a little flip chart for emergencies, media inquiries. If I recall correctly, media inquiries were sorted under mental health crises. So I don't know what that says.
Well, that tells you a lot about how stressful connecting with the media can be.
All right. I think that's a good place to end. Thank you for joining us this week, and we'll see you next week, right?
Yep. We'll see you next week. Thank you, Steve, for joining us.
Music for today's episode is Hybrid Trailer Epic by Alex Make Music from Pixabay.com. Because I forgot to mention it, Steve Desch is a professor at the School of Earth and Space Exploration at Arizona State University. You can read more of his work at slate.com/author/Steve-Desch, DESCH. Global.Science is a production of Science Voices, a U.S. nonprofit. Please give us money at www.sciencevoices.org.